What's up? I'm Austin Griffith. I'm here with Carlos and Etta, and we are recording day 3 of week 1 of becoming a power user in Ethereum and learning how to build on top of Ethereum. Today, we're going to use our wallet to interface with some Web3 services, and we're going to learn about identity and how it follows you. Your identity and your inventory follow you from service to service. And also, all of these services are backed by smart contracts, and we'll get to smart contracts and how that all works. So I think the best place to start is if Etta creates a brand new account in her MetaMask, and then I'll send some ETH to it, and then Etta registers an ENS address. Should we start with that? Go ahead and let me set it up so you can share your screen. Go ahead and share your screen and just show us how we would create another address within our MetaMask that we've already set up. So last week, we kind of set up a MetaMask. We learned about our seed phrase. We learned about how to protect it, what levels of security we need for 2 different things. So this is just creating a new account within an existing MetaMask, right? Given one seed phrase, you can create as many accounts as you want. And let's see what we got here.
I've already got like 4 accounts here, and let's just create a new one, and let's call it, since we're on Zoom. What
are we going to call it? Zoom? Zoomy.
Not very creative. But yeah, okay, so I am going to go to mainnet right now. And yeah, I have my like different networks. We had set like the test networks. I have a couple of other ones as well here. But yeah, so I have a new account just created 2 seconds called Zoom. And
all right.
We are.
And if you send, sorry, go ahead. If you send me that account, I'll send you some ETH so you don't have to pay for the swaps and stuff.
I'm just sending it to you from
okay. And I'm going to steal the screen back, and I just want to show me slowly going through sending some ETH, right? Oh, sorry for my messy desktop. Jeez. So when you want to send ETH, thankfully, thanks to things like EIP 1559, sending ETH has gotten pretty easy and smooth. Like the gas estimations are pretty good, and gas is pretty smooth. Now and then there will be an NFT drop and gas will spike way up. But if you remember from last week, we talked a little bit about like basically gas is you spending a little bit of ETH to send or make some kind of transaction, and you're kind of bidding at some limited block space. So if it gets busy all of a sudden, the bids go way up. But yeah, Etta, if you send me that address, oh, I got it. There we go. So notice that when she's sending me the address, it's this big old address thing. Let me show you. She sent me this right here, right? This AE9459. That's really hard to keep track of, right? At least we have these nice little like blocky previews, so we can kind of have a little visual look about what these addresses look like. But handing these things around is kind of cumbersome, right? It's hard. Like imagine if you had to retype that or something. You would never want to do that. So we're going to get to ENS here in a little bit, where we kind of give a name to an account, and then it's easier to refer to and to send around. But right now, I just want to send a little ETH to this account, right? And I'm kind of looking at the gas tracker. Oh, gas went up, right? It went from 80 to 100. If we had put in a transaction right at 80, we'd be waiting right now for that to get mined. So I'm just going to open up my MetaMask here and hit send and paste in Etta's address and send like 0.2 ETH or something like that, 0.25, how about that? And normally I just hit next and hit send. I don't usually have to look at the gas very closely, but let's just take a quick peek at it just to see. So there's kind of like some different settings. Again, you're bidding to get your transaction through. You could bid a lower amount and that transaction will go through slower. You could bid a higher amount and it will cost more and the transaction will go through faster. But if we really look in here, it's basically setting us up at like 129, which is well above this 92 that we're seeing here. So this should go through right away. Actually, let's cool it down. Let's put it right at 91. It's saying, oh, that's not a good idea. let's try it, and it's just going to make the transaction take a little bit more time, and that's okay. We can even speed it up. But there we go. So that's going to go into the mempool now, and all the miners are going to see that, and they're going to greedily pick the best transactions that will make them the most money and mine those into the next block. So we're just kind of like waiting for that gas to get down to 91. And if we wait a second here, and this still is 75, look at that. I got in way cheaper than they were. They were probably going to charge me $8 and I only paid $5 for it. How about that? So we got through, the transaction went through. Hopefully, Etta, now you have that. And we can go to a disinterested third party and we can hit reload and we can see, sure enough, AustinGriffith.eth sent 0.25 ether to whoever 8A94 is, right? And we can kind of see that as from a third party. So we know that went through, and I'll hand it off to you, Etta, if you want to take over, and we'll do some ENS registration.
Yeah, that was a really fast transaction.
Yeah, at low gas too. A really fast and efficient and cheap, right?
Yeah. So it directly came to the account. We're on Ethereum mainnet. So yeah, if you're like on another network, you won't probably see it. So just be sure to like have the correct mainnet. And now I'm on ENS. So this is like ens.domains. And we're basically going to go to the app so that we have like a better name, like nick.eth or something else.
Kind of like DNS. I think, Carlos, you hinted at kind of like explaining how DNS is similar to ENS. Do you want to speak to that?
Yeah, I mean, when you think about DNS, if you try to remember the IP of the server that you want to connect, it will be like super hard, right? So yeah, so this is the same thing. If I want to send like ETH to Eda, if I have to remember her full address, it's going to be super hard. But instead of that, she has like something like eda.eth is going to be super easy to remember. So it's kind of the same thing, like names to IPs or names to Ethereum addresses, right? And it have like the same concepts like subdomains, for example. You can also have, when you have like an ENS setup, you can also have like, game.eda.eth, for example. So a lot of the same concepts apply also to ENS.
Subdomains are really powerful. I use them for a lot of things. Like you can go to, I think it's lol.atg.eth is my multisig.lol, or there's just like a handful of different accounts, like secondary identities that are just like subdomains of my main identity. Speaking of that, do you have eda.eth? Right? Yeah, like Punk Wallet. Yep. Punk wallet. Yep. I have punk.austingriffith.eth is my Punk Wallet. Do you have eda.eth? EDA.eth?
Someone else has eda.eth. I have eda.tweets.eth, like, but I miss eda.eth.
Yeah, and those three-letter ENS blew up. Yeah, those like are expensive. Yeah, you probably have to pay a couple $1,000s for that if you want it now. I think that the price floor on three-letter ENSs is way up. Okay, so ENS is like a good way to put a name to an address so people can address you by an easy name instead of having to copy or paste a big address, just like in DNS where it's like, no, you don't want to have IP addresses where it's 127.22, right? You want to have, austingriffith.com and go straight to it. So let's register an address for our new account here and kind of create an identity around this new account, whoever Zoom is.
Yeah, so I just wanted to show, like, when you log in, it will display a pop-up on your MetaMask and ask you which account you want to connect to. So just zoom.eth, connecting, just ask me to connect once again.
And this is a security
Now
thing.
we're in the app.
Yeah, we talked about how MetaMask is security first, right? They want to be very careful about what information from your wallet they share with the app. They don't even want the app to have your address until you explicitly say, okay, let's talk to this app. So that's what that extra like account selection is like, are you sure you want this website to even know your address? And you say, yes, connect it in, and then we're connected in.
So yeah, like it's just as if you're searching for like a domain name over here, and we can actually show that eda.eth, someone else has it. Or maybe do I just write eda? Oh no, I just have to write eda, right? And then it will. Yep. Okay, yeah. So someone has eda.eth. And you can kind of see until when they have it, who has it, etc. But just to kind of show an example. So yeah, let's register a name, a creative name.
I don't think our wallet is connected either. Like, see in the top left where I think you basically logged into your, but see in the top left, it doesn't show that it's connected. Usually there's a connect button within the app. And when you hit that, it prompts the wallet. Let's see what happens. Yes. Okay. Yeah. So MetaMask there, now we're connected. Okay. So two things have to happen there. You need to tell the app, I want to connect to my wallet, and you need to tell the wallet it's okay to connect in. And we just told the wallet it's okay, but we forgot to tell the app to connect. So when you land on a Web3 app, you're looking for that connect button and you connect in, okay it in your wallet, and now we're logged in and we can see who we're logged in as. So
also like
the
app only has read access to your wallet, right? So don't worry, because it's not going to steal your funds or anything if you are not signing anything. It's just like saying, okay, I give it like read access to this app, so it can read basically my address, right? It's the only thing that it can read.
That's a great point. And your mnemonic is locked up in the app, and your private key is locked up not in the app, in the Chrome extension, right? All of that sensitive data is locked up in the Chrome extension, encrypted with that little password that we put in at the beginning. So yes, like there's like this nice, like kind of big protective wall within this Chrome extension. And we're throwing transactions over the wall, and then we're signing them and we're throwing them back, right? So the private key and none of that stuff is ever exposed. The only thing we're really exposing to the site is, hey, this is my address. And then whenever you want me to sign something, you kind of chuck it over the wall to the wallet. What are we going to name this thing? Zoomy Web3, Zoomy Education, Zoomy. So Zoom is going to be taken, right? Zoom.eth is definitely taken. What do we can search it's like that too. What about Web2 to Web3? Let's see if anybody has that one yet. I bet someone
it's a
does.
Good one, actually.
That's definitely like something someone would squat on. Yep.
No.
Maybe like Web2 to Web3 developer. Is it too long?
Ooh, sure, let's go with it.
A bit too long, but
yeah, but no one's gonna have that. There we go. Here we go. Web2 to Web3 developer. It's kind of long. I don't know.
We could have like Web3 developer.
Ooh.
Okay, this can take a long time, so I continue.
Like maybe like Web4, so we are ahead of time. No? Web4 developer.
Yeah. I bet someone's squatting on Web4.e.
Like waiting for the Web4 to. Okay,
Yep. Yeah, IDK. I mean, no one's gonna have that one.
This one's available, yeah.
What about web? I don't know. I mean, it could just be anything. We could just do like a random name generator, right? And just like get a name. Hold on. I'm just gonna go randomly generate. Oh, these are like weird. I want like a character generator. Like I'm about to go on a quest. Here we go. Oh man, these are good. Sanford Stout. Look at this. What do you think about Sanford Stout? I just went to a name generator and see if that's taken. Just a random name. What we're hinting at here is Sybil resistance and how anyone can make. There we go. Sanford Stout.eth. Anybody can make an address.
It's a good one, yeah.
Yeah, and make it, and now it looks like it really like it already is taking on an identity. I'm already thinking of this person Sanford. All right, now we can register it for many years or just 1 year, and it's a little bit more expensive, right? And the trade-off here is like, are you going to use this name a lot? You can, because you have to make a transaction every time you update it, right? So you're going to have to pay some gas every time you want to renew this thing. So you want to renew it for many years or just one. We probably just want one, right? We're just doing a demo. Yeah.
Yeah. Maybe Stanford can get it afterwards.
Yeah, Sanford. Yeah, Sanford. It'll be all you. Yeah.
And Sanford Stout. So
yep.
So we can just get it for 1 year. It says the gas fee as well, but I think MetaMask will prompt us.
Yep. Yeah, it should handle all that stuff for us. Yeah. Yeah. Me diving into the gas menu and going to the advanced menu. I don't think we need to do that ever again until we're talking about like front running or getting a transaction stuck and needing to speed it up, which maybe we'll run into that organically, but I think let's go for it. So some weird things happen here. I think there's even like a commit reveal. There's some kind of game that you have to play here, where when you request to register it, someone else could request it, or I don't remember. I don't know the inner workings of the ENS platform, but you have to realize that like anybody can attack any of these things. So you have to think of these things very adversarially. So I don't know if someone is like could front run this, but there's this game that you have to play here. Go ahead and click to request to register, and let's get it rolling, because it like there's like a delay that has to wait. Okay, so this is different than sending ETH, right? This is probably the first transaction we've seen on this kind of Web2 to Web3 curriculum where we're talking directly to a smart contract, and it looks a little bit different. If we go to that data tab, we can probably see that we're sending, yeah, we're calling the function, we're calling the commit function. So we're going to do a commit reveal. We're going to call commit, and we're going to send some information into the smart contract. This is more information than you need, but we're just really kind of picking away and looking at this stuff. Really, from a high level, we're just using our wallet to talk to a smart contract. We're sending a transaction that says we would like to commit to registering Stanford Stout.eth. And once we do that, then there's like a delay, and then we reveal. So it's going to cost us $5. I'm just assuming that gas is fine. Gas is at like 51 Gwei, super cheap right now. Let's send it. Let's see how it works. And if it gets hung up and the transaction takes extra time, we can show how to speed up a transaction. But thanks to EIP 1559, that there's a lot of things that have caused the gas to be a lot more stable. So usually transactions go through. We'll see what happens here.
Yeah, so yeah, as you mentioned, I think it's 1 minute. We're going to kind of wait.
It won't, the waiting period won't even start until this transaction goes through. So right now we're just waiting for, we've signed our transaction, we've put it into the mempool. We're waiting for a miner to pick it up. Let's speed it up. Let's go through it, right? Oh yeah, here it is on the block explorer. It still says it's going to take less than 45 seconds. We can probably just wait a little bit. Like nothing has happened to have the gas spike. What if we scroll down, we can tell how much Gwei it's using now. So yeah, 71 Gwei, and the gas price is 61 Gwei right now. So it's about to get mined. Like we should see, and all of this, like there's the commit function. You can get on Etherscan and really like get in here and see what's happening. So we're talking to this smart contract, which is the ENS ETH registrar controller. There it is, success. We've set the first thing, and I bet now our little, yep. So now we're waiting, and I don't know exactly what the game theory is here, but you have to like commit to the name. And then if no one challenges it, then you reveal the name after a minute. And somehow that avoids some kind of griefing that I don't understand. Just assume that the smart contract nerds have figured out the game theory here, and we have to play this game to be able to register our new name. Sanford. I've got a good feeling about Sanford. Now we're just waiting.
I didn't know
it
was a name.
Yeah, yeah. It's better. I was saying like Jimmy something, and that just sounded too American. I'm glad we went with Sanford. Sanford sounds like a man of class. like someone who would wear a bow tie on a Friday. What a dork. We're almost there. We've almost waited our minute. Hopefully someone named Sanford Stout is like on their computer somewhere in the world wanting to register their ENS name. They're like, oh, dang, it's
just taken. This moment.
Yeah. Okay, we've waited our minute, ENS. There it is. And we have a register button. So now we make our second transaction and we pay probably another $5. Whoa, this one's a little more expensive. Yep. So this one is probably, what's happening here is we're probably getting an NFT and we're making more rights to the smart contract. So whenever you write something on chain, it's a lot more expensive. And so this one's probably changing some state. It's not just like a simple transaction, but here we go. Oh, it's even cheaper. Gas is going down. Let's send it.
Yeah.
All right. So we're waiting for that transaction to go through. Again, same thing. Like we go look at it on Etherscan. It should say, oh, it hasn't even figured out how long it's going to take yet.
Oh,
there we go.
Figured it out.
Yep. And so if we scroll down, do we see more? What is this function calling? Probably reveal or something, right? Register with config. And there's a secret there, and that secret is is the reveal. Yep. Ooh, nonce 1, right? We can talk through the nonce. I think we talked a little bit about nonce and replay protection in the first, but your nonce is here, and we can see this is nonce 1. So it's basically your second transaction because it's 0 indexed.
So I guess like the reason that they are doing this commit reveal is because if not, like people will like steal your ENS, right?
Yes.
Like they will see the transaction with your ENS name, and they will maybe like send another transaction with a higher gas price, right? And they will like steal your ENS from you, and that's why they need to do it this way.
Interesting. So it's like front running ENS registration. You could just watch Vitalik's address, and anytime he interfaces with his contract, you put his exact information in, but at one higher GUI, and then you'll steal every name he tries to register. Yeah. So the commit reveal kind of gives you a hook in on it, and then you kind of reveal it later to get it back. Cool. And it has to be the same address. Like whoever reveals the secret has to be the same address, and it has to hash to whatever the commit was. And that lets you lock in the name. That's got to be it. Good call. Did you just look that up right now, or did you know that?
No. I wasn't guessing. I don't know.
Dope. No, I think that's right. Oh yeah, and token ID. See, we minted a token. ENS is like one of the first NFTs, which is really interesting because it's like this non-fungible token before non-fungible tokens had the name non-fungible token. But it's sort of this token ID with this huge number that we own, and we own that new token ID that goes to Sanford Stout.eth. There we go. Okay, so now if we were to, let's go look up, let's copy and paste Sanford Stout.eth and paste it into Etherscan. So if we were to just go to Etherscan and ask it, who is Sanford Stout? It should be able to tell us that it's this address. Yes, awesome, which is really awesome. So now if I were to pull up my, let me steal it for a second. If I were to pull up my wallet and type in Sanford Stout, look at this. So this has nothing to do with the ENS website, right? I could be over on something else, right? I'm just opening up my wallet now. This is kind of showing how identity goes from service to service. Now, if I type Sanford Stout.eth, yes, there we go. There is our new, and we can see it matches the ENS. And if I send another 0.01 and hit send, there we go. So this time I didn't have to get some weird address. I can just remember Sanford's name is Sanford Stout. I'm like, oh, Sanford, let me send you some. Sanford Stout.eth. Boom, I send it. Boom, it's done. And there's no like copy and pasting and weird triple checking of addresses. I kind of looked at the blocky a second to make sure, but it was a lot easier to send you ETH this time when you had a name rather than when you had the address. But we've only done 2 of the 3 transactions. So we have one more transaction, and that's the reverse record. And what the reverse record allows you to do is if someone says, this address is logging into my website, how do I look up what the name is for the address? So instead of going name to address, we want to go from address to name. And the way to do that is you basically, it's nice, it's set your primary ENS name. ENS has done a really good job coaching through the user experience to here, and you should be able to pull down on that list, and it should have Sanford like as the default on that list. Yep, there we go. Perfect. So you'll do that.
So before,
go ahead.
So before doing this, like if you send money to like Sanford Stout, it will come, or like I'm not exactly sure. Like after this step.
This step is doing the reverse record. So right now, basically, I can send money to Sanford Stout and it'll totally work fine. Okay. It's the reverse of if I only know this user, this account, right? This 0xA894, and I want to know who that goes to. This sets that up. So this is almost for like when you log into an app and they only know your address, they can go look up the name for that address and display it. And we'll see that when we go swap some ETH in a second.
Okay. Okay. So I guess, yeah, saving it.
Save it. Yep. Let's do it. Nice. And they even say something like, this is your cross-platform Web3 name, right? It's very like, it says it back behind there. Yeah. So another $23. So what was it? Probably like about $60 to register this, $60 or $65.
I think we paid something like that.
So kind of expensive, right? But remember, this isn't your name for one thing. This is your name for all of Web3. This is every app that you go talk to from now on will know you are Sanford. And whenever anybody wants to send money to Sanford, they can just type in Sanford Stout and send it, right?
And it's a lot easier, yeah. Like instead of remembering this when you are like out and trying to send money to each other.
And another interesting thing here is I can register and point ENS addresses at lots of different, I can point names at a lot of different addresses, but to do this specific action where you point some address to some name, it takes a transaction from that exact address. So if like you have a multi-sig that you want to have behind, like I said earlier, like a subdomain or something, you basically have to have that multi-sig make the transaction. And that's just out of safety, right? You wouldn't want someone to be able to spoof someone else's name. So the only way you can set the reverse record is to make a transaction from that exact account. And it's got to be through, right? Did it mine? Are we good? We didn't get any feedback here. Welcome to user experience on Web3. Yeah, 1 minute ago. We see that it went through. Yep.
Yeah.
Great check there. Cool. So I've sent in twice and I've sent, okay. So now we have our identity. We've registered an ENS name. We've talked to a smart contract. We've made a transaction. And now we're registered in the ENS registry as Sanford Stout. And now Sanford Stout can go use other services within Web3, and his identity and reputation and inventory will follow him from site to site. I think he's a dude. I shouldn't be, assuming, but I've just been calling Sanford a he. Whatever, Sanford. Sanford is about to go swap some tokens, right? We're going to uniswap.org and we're going to swap ETH to a stable coin. Okay, so here we are. This is what a typical Web3 app looks like, right? There's some stuff going on, but the connect button is that most important, right? You're looking for that, even a network, right? Now that we have L2s, you've got Wallet Connect, Coinbase, some other accounts, but we're just going to use MetaMask. We make sure we have our Zoom. We call them Zoom. We should probably rename that to Sanford now that we've given it a new name. But Zoom is our Sanford account. Yep. And we connect it in. Now look what happens. Oh, nice. Wow. Our name has followed us, right? No matter what app we go to, as soon as we log in, they're going to know we're Sanford Stout, and that's going to show up, right? So two completely disconnected services now can use the same exact identity, and that identity is going to follow you from place to place. Should we do a swap? Should we make it happen?
Let's do a swap.
Maybe like 0.1 ETH. Yeah. Go ahead.
Yeah.
Sorry.
It gives us like the different options. Like we just have ETH right now, but you can select if you have multiple tokens. But yeah, let's select a token to swap it to.
And all of these tokens, right? The first, if we think of Ethereum as an app store, right? Basically the thing that we're using Ethereum for so far is just sending around value. But now if we think of it like an app store, the first killer app deployed on Ethereum is an ERC20 token, right? Instead of to create a decentralized currency, before this, you had to like create an entire platform of peer-to-peer miners. Now with Ethereum, all of that substrate is taken care of for you. You can just deploy a smart contract that keeps track of everyone's balances, and you can create a decentralized currency in a couple of lines of code. And so any of these given currencies, DAI, USDC, USDT, WETH, all they are is just a smart contract that's keeping track of who has what, and a transfer function that lets Alice, send some to Bob, and it changes that mapping of who owns what. So let's just swap to DAI, the classic, and DAI is a stable coin, and we should get in and talk about that a little bit more. But here we go. So what's happening here is we're going to put in 0.1 ETH, and we're going to get out 206 DAI. And when we're ready to pull the trigger, let's go for it.
Yeah, it also gives us a gas estimation, but it will already appear. Oh, it gives us it again.
Yep. And then when we hit confirm, notice it brings up that MetaMask, right? You kind of work in the app for a little bit, and then it sends it along to MetaMask. And we can kind of look at, okay, so it's going to cost us $32 in gas, and then we're going to send in a total of $239 to go in, right? And we can confirm that and ship it. So the token, right? Anyone can go ahead, Carlos, go ahead, please.
No, I was going to say that maybe we should like explain what Uniswap is or what are decentralized exchanges, because people, if they are just like watching this, maybe they don't know what we are doing, because we talked about Coinbase the other day, I think, about where we were talking about wallets, about having like custodial wallet or non-custodial wallet, but we didn't talk about centralized exchanges or decentralized exchanges. So
Perfect.
Maybe any of you could like, do like a brief introduction.
All right, here we go. So usually a centralized exchange, just like our custodial versus our non-custodial wallets, our custodial wallets were basically entries in a database, right? And our non-custodial wallets are like, we have a seed phrase that can move things. So a centralized exchange is basically like an order book system. It's a big database of who's willing to pay what for what tokens. And then a decentralized exchange is a smart contract that keeps reserves of both the tokens and allows you to swap between the two right in the smart contract. So there's no centralized point of failure. With a centralized exchange, there's a database and there's all sorts of stuff that could get attacked or fall over. So this is a really big it's a really big step for decentralization to figure out how to have a smart contract allow you to swap from tokens to ETH. And it does it in this really clever way where the smart contract itself holds reserves of both. So we just went and we swapped in a smart contract that held a whole bunch of Ethereum and a whole bunch of DAI. And it holds them at the ratio that they're currently valued at. And as the price of Ethereum or changes, the price of DAI kind of adjusts, and then there's basically bots that swap those and create, it's called arbitrage, right? They see that Ethereum is cheaper over on one exchange and they grab it there, and then it's more expensive on this exchange and they sell it there, right? So there's these reserves that are stored in the smart contract, and there are bots that are trading those things to keep the reserves at the right ratio for the current price. And then when we want to come in, imagine it like a vending machine. We put a little ETH on the scale, and the scale goes right, and then we take off a little token, and then the scale evens again, right? And that amount we take off basically is like what they return to us. So that's a quick and dirty. In week 3, we will build a decentralized exchange, and we will really look at the Solidity code, and we'll look at the price function, and we'll understand how these reserves are backed by this like LP token that is like your share of the reserves. Oh, by the way, those reserves, you're earning a fee on those reserves, right? You as the liquidity provider are incentivized to put your ETH in, so then when people swap back and forth, you earn a little fee. And that also zooms in on the fact that this decentralized exchange is not run by any particular person. It's a smart contract that has a set of rules, and anyone can provide liquidity. Anyone can provide both ETH and DAI at the right ratio and own a little bit of the liquidity, and therefore own a little bit of those fees that are coming back to them. So really, really cool concept. Just want to like scrape the surface there. Really, really cool concept to go from, if you wanted to swap tokens and ETH 4 years ago, you basically had to go to an order book system and sign a message, and it goes to a centralized server, and everyone else is going to this central website, and that website could fall down if there's too much traffic to it. It could get hacked and someone could drain everything. The whole like custodial versus non-custodial. And now we have like a smart contract written that can handle that, and like many versions of this smart contract that has gotten better and more sophisticated, and things like Balancer where you can keep things at different ratios. The new Uniswap does like this really cool like liquidity it's efficiency, right? Where since we're holding reserves, you can hold all your reserves in a certain range where you think people are going to be swapping, and you can earn more fees. That's way too much though. We're gone too far. We're too far into the DEX. Hopefully that like shows a little bit though about the difference between a centralized exchange and a decentralized exchange, and how you basically can make a decentralized exchange by just deploying a contract with the correct rules and loading it up with both of the tokens and letting people swap between the two using just the smart contract, and nothing that can fall over and nothing that can get attacked. Sorry for the long-winded
great.
explanation.
That's great. Yeah, thank you.
Okay, so we swapped. Do we have some DAI? And at this point, we can talk about, so the one thing I wanted to show is if you take Sanford Stout and you put it into like zapper.fi, I want to show like another, so we've seen Etherscan, we've seen ENS, and we've seen Uniswap, and we've seen how our identity follows us. But go ahead and just put our identity, let's not even connect our wallet. Let's just put our identity right into that search box. And let's show how Sanford Stout's whole inventory follows them to this new site also.
I think I have the name wrong. Let me just check our name. Oops, can't check over here.
It's yeah, Sanford Stout. So it's not Stanford, it's Sanford, right? Yes, A-N, yeah, F-O-R-D, yep, that's it, .e.
Yeah.
There it is. There we go. Okay, so here is our character, and our character has an inventory, and that inventory, like Zapper doesn't know who we are and doesn't give a shit about any of that stuff. The inventory is what he's interested in, and here it is. We can see that we have $237 worth of ETH, and we have $200 worth of DAI. We don't have any NFTs yet, but they can kind of follow our history. So notice, like, this is a fourth website we visited. A fourth disinterested third party. And this is an example of another just like Web3 site. You go here and you put in a name and it knows who you are, and it knows your history, and it knows your inventory. So this really hammers home the idea that like your inventory and your identity sort of follow you from place to place. And a secondary thing is identities can just be created. We just invented Sanford Stout, and now he's going to go like start interfacing with Web3. He's already swapped to some stable coins. Who knows what he's going to do next? Maybe go buy an NFT or something, right? So Sybil is very important, because as we talk about these mechanisms that we're building, or voting and one token, or one vote, one human, it gets really, really sticky here, because we just created what looks like a human that isn't a human, right? And so Sybil resistance is another thing in Web3 that is an unsolved problem that a lot of people are spending a lot of time thinking a lot about. The other thing we should talk about is just like a stable coin, right?
Yeah.
The fact that this is like, it's just bad user experience, that $237 of ETH that we hold is going to be worth either $200 or $260 in the next 3 hours. The price will fluctuate greatly over the next couple of days, and it has recently, right? So this is really bad user experience. If you provide a service to me and I send you $100 worth of ETH, and then tomorrow you look at your money and you only have $60 worth of ETH, it's kind of like a punch to the gut, right? Like when you lose money like that, right? So DAI is a stable coin. DAI is an ERC20 coin that's deployed to Ethereum that you can swap to. It's a standard ERC20, but it is pegged to the dollar, tries to stay as close to the dollar as possible, using some pretty advanced mechanisms, right? If we wanted to look at it at a high level, and I can try to TLDR it, but I'm not great at stable coins. Think of the price of something is basically like a supply and demand, right? If the supply is high and the demand is low, the price is going to be low. If the supply is low and the demand is high, the price is going to be high. You know, economics 101. So the first mechanism of keeping this coin stable is like a minting and burning mechanism, where if the price drops to, let's say it's at 10002, right? So it's a tiny bit above $1, right? So what's going to happen when it's a tiny bit above the dollars? We want the price to go down a little bit. So they're probably going to mint some more and increase the supply. And by increasing the supply, the price should go down a little bit. And then if the price is too low, we should be able to burn some, right? And what they'll do is they'll mint them and market sell them or burn them, something like that. And again, total hand wavy explanation here. Go read how DAI works because it's so cool. But then there's like a secondary mechanism where if burning it is still not causing the price to go up, then they have this second token called maker, and the maker token is then starting to burn, right? So and I think I totally left out the fact that to get DAI, you don't usually swap. I mean, you can swap to it and that's easy, but the way to actually produce DAI is to lock up ETH. So there's like a lending mechanism here too. To actually like generate DAI, you can lock up ETH and take what's like called an over collateralized loan. So I can put in $100 worth of DAI and I can take out $60 worth of ETH in a maker vault. And I'm sorry, I said that wrong. I put in $100 of ETH and I take out $60 worth of DAI. And that's over collateralized. There's more ETH locked up. There's more ETH in terms of value locked up than there is DAI that I get out of it. And then if anything happens where the price of the DAI is worth more than the ETH that's in there, then you can get liquidated. So there's this supply and demand thing where they're minting and burning. Then there's this over collateralized loan that protects that. So for every DAI that's in circulation, there's ETH locked up. And if any time the DAI in circulation is higher than the ETH locked up, people's loans can start getting liquidated. And there's a thing in the smart contract that just lets you liquidate someone's loan, and that's crazy. And then there's this maker mechanic where if all of that still fails and you need more value, they start like destroying the maker, and that value goes into buying DAI, and then that should increase the price of the DAI. Something like that. That was a wild explanation. It was all over the place. Hopefully that kind of makes a little bit of sense. I probably like the maker guys, if they ever watch this, are going to be like, he's totally wrong. But think of supply and demand. Think of like secondary tokens to back up the first token to help sell things to prop up the supply and demand. And then think of like over collateralized loans. So you have more locked up than you have in circulation. And if that ever changes, there's a liquidation mechanic. A lot goes into making a stable coin stable. And we've recently seen a stable coin crash. And the reason was that it was that over collateralized loan didn't work. Like the mechanics of there was a collateralized loan, right? And the market went down. And so all of a sudden the collateral wasn't worth as much as the token. So then what they needed was this second token to start selling off to cover that. And then that crashed too. So it's like both of these things crashing at once sent it into a death spiral. And it works different than the way DAI works. Maker and DAI have a different system that's more stable, that doesn't have this death spiral thing. And so the token that shall not be mentioned has gone from worth $1 to worth $0, and billions of dollars have been lost because of it. Because they had this thing where it, like the mechanics of how the token worked didn't it causes death spiral thing. And that's like also like way over my head, but hopefully like some of this is like getting exposure to you at home who's building this stuff, knowing that there's these like complicated systems that thankfully for you keep this nice token stable. That look at that, it shot up. Just yeah. it's worth a whole $1 and a penny right now. Should we sell it and make some money? So yeah, anything to add there? Sorry, my long-winded stablecoin talk, but does that kind of cover it? Does it kind of make sense? Okay, cool. So what's cool here is if you go back to our profile where it shows that we have ETH and DAI, we have a similar amount, right? We have $237 worth of ETH and $200 worth of DAI. If we come back to that in a couple of days, those numbers won't be so close. Probably ETH will be worth more or ETH will be worth less, but I'll bet you that DAI will be right around $200. Which is pretty cool. That is a much better user experience. If you're building an app, you're paying people in DAI, people are paying you in DAI, that DAI is going to stay stable.
Yeah. So exactly. I just also kind of wanted to show over here after we swap, because it's not on our MetaMask at the moment. Like you can see it on Zapper, but you don't have like DAI over here. So we could like manually add it.
That's network though. So yeah. But it's in assets. Yeah, there's an asset. Yeah, right there. Yeah. Yep. So we see that we own ETH, but we have no idea that we own any DAI because our wallet's not tracking it. but we could go see on Zapper, oh, sure enough, it is tracking DAI. That's great. Let's add DAI to the wallet. That's an awesome call.
So we could also add from here, or you could directly click
Oh,
like
nice.
add DAI to MetaMask. I think we can just add it from MetaMask itself. Import
see what
tokens, I
happens.
believe if I just click DAI, then you see
Well, that was smooth.
import. Because it's sometimes you switch and then it's like, oh no,
Yeah.
like where did my tokens go?
Right,
Yeah.
right. Yeah, totally.
So now we can see it in the MetaMask.
And we can see it on Etherscan too. If we were to put in Sanford, Stout, and Etherscan, we should see that Sanford owns, yeah, you can see value 235, but then you see tokens 207, right? And you see the tokens in there. Oh, and a 721. We have our first NFT also.
Yeah.
What happens when you click on that? Does that take you to just like an NFT view within Etherscan? Cool. Oh, look at holders is almost at 400,000. We were almost the 400,000th ENS holder.
A lot of ENS names.
Yeah. And we know from Sybil resistance that 400,000 holders does not mean 400,000 humans, right? It means 400,000 registered names, but there's no Sybil resistance. Yep. Neat. What else do we have to cover today? I feel like we ran through most of the stuff. Identity is just tricky, right? We kind of talked a little bit about identity here. We've created this Sanford Stout, but if we tried to have some like top-down identity system, it would be really hard. Like there is no real universal identity. We'd love to have some kind of identity, but I think most identity providers are doing this top-down thing and it just doesn't work. It seems like identity is more like emergent and it's more about context between local interactions. So how you build up identity, if you're building a decentralized app, probably has to do with who comes in and how do they interact and how do we even want them to be one token, one vote, and how do we prove that? And token drops right now are a good example of people who are trying to do Sybil resistance, and they look at, you know, account activity. Has this account voted in Snapshot? Has this account signed a multi-sig message? Has this account done human-like things? Or is this account like a bot that's doing bot-like things? And then if it's doing human-like things, we apply a higher score to them. And so there's more like this kind of gray area scoring mechanic of how human the account looks. Okay, man, we've covered a lot of stuff here. Anything else that we're missing? I think we got it. Anything else to close it out?
I think one note on like the DEX part is, especially when building the DEX project, it was really helpful. Like you can see the different, like it's kind of hard to understand in the beginning, at least for my case. It's like, okay, I'm swapping this, but how does this actually work? I didn't really deep dive into it. But when you're building it, you kind of get to understand, okay, like this holds this much, this holds this much, and then that's why the price changed. So I think that will make it a lot more clear once building the project. Like right now, it's just, I want them, but
don't worry if you don't understand the DEX right now, for sure. It will make a lot more sense. I almost imagine it like a vending machine. And I put either some tomatoes or some dollars in. And if I put in dollars, some tomatoes come out. And if I put in some tomatoes, some dollars come out. And I imagine that scale in there, right? That's holding, you know, there's hundreds of tomatoes over here and there's hundreds of dollars over here. And when my dollar goes in, it makes this more heavy. So I have to pull out some tomatoes to even it up again. But yeah, I just think of it like a vending machine. We're building these really giant, we're building these really interesting, censorship resistant, unstoppable vending machines. And we went to one today and we got a name, and we went to another one today and we got some stable coins, and our identity and our reputation kind of followed us from app to app. And we, in a way, we kind of Sybil attacked Ethereum, and we created a brand new human that isn't a human, and that leads to some existential dread. But I think we're becoming a power user. We've used our first app, we've used our first service. And what that means is just using our wallet to sign a transaction that talks to a smart contract. And we're going to get farther and farther into that as we go. But I think we've made it through day 3 of becoming a power user. Yeah. Thank you, Etta and Carlos. Sorry for all the mansplaining. Happy Bow Tie Friday. All right, see you guys next time.
See you.
See everyone.